In previous lecture, we have seen that these vectors cannot be added or subtracted by using the algebraic operations like addition, subtraction, multiplication, and division. So there are different rules for the vector addition. Okay, so the first law for the vector addition is a triangle law of the vector addition. Okay, I'll write the statement over here. If two vectors acting on a body and represents two sides of a triangle. So this represents both in magnitude as well as direction. Okay, this term is important. Represents both in magnitude and direction. Represents two sides of triangle taken in order, then third side represents a resultant. This also both in magnitude and direction. Resultant taken in opposite direction. So I have written this statement because you need to write down the statement in exam as it is. See here what the statement says. If the two vectors are acting on a body and represents two sides of the triangle. What does it mean? If there are two vectors which are acting on a same body and taken in order, what is mean by this? So this term is very important. Taken in order. Okay, so if these two forces are acting on a body and which are taken in order, okay, so what is mean by taken in order? The tail. Okay, so this is called as the tail of the first vector and this is the head of the first vector. This is the tail of the second vector and this is the head of the second vector. So if the tail of the second vector is on the head of the first vector, so this is called as a taken in order. Okay, so if the two vectors acting on a body represents two sides of the triangle taken in order, then the third side represents the resultant. Okay, both in a magnitude and direction and taken in a opposite direction. So in order will be like this. Now this will be like this. So this is the opposite direction to the, so what will be in order? In order vectors will be like this. So this will be in order. Tail of the first is on the head of the second, tail of the next is on head, tail of the next is on head. So these are in order. Okay, but the third side represents the resultant taken in a opposite direction, taken in a opposite order, we can say. Direction is also okay, direction in a, so for this I can write that as vector r is equal to vector a plus vector b. So this is the resultant vector r, which is vector a plus vector b. So the vectors which are acting on the same body and if they are representing the two sides of the triangle, then the resultant could be given by the third side of the triangle taken in a opposite order. So this is the statement of the triangle law of the vector addition. If the two vectors are acting on a body and representing the two sides of the parallelogram, okay, suppose this is point O. Now I will call this as a OA and this as a OB. Okay, so if there are the 2 points, if there are the two vectors which are acting on a body and representing the two sides of the parallelogram, okay, so this will be a parallelogram. Okay, then the resultant is represented by the diagonal both in magnitude and direction of the parallelogram starting from the same point. This is the statement. I will write the statement. So which says that if two vectors acting on a body represents two sides of parallelogram, both in magnitude and direction, then resultant is represented by diagonal both in magnitude and direction, starting from same point. So if there are two vectors acting on a body and which are representing the both sides of the parallelogram, okay, then the resultant is given by the diagonal starting from the same point. This is the uh, law of the vector addition. Okay, parallelogram law of the vector addition. Okay, so let us draw a parallelogram. So this is point A, so this is vector A, this is vector B. Now if I complete the parallelogram like this, so this OA and OB, they representing the two sides of the parallelogram, and this would be representing the diagonal. Now if I draw, let name these as, this is OA, this is OB, let this point be C, and let us call this OA as vector P and this OB as a vector Q, and let call this as a vector R. Okay, and let call this point as a D. Okay, now if I take this small triangle, a right angle triangle, so this is ACD, and if I try to write the sine theta into this, suppose this is theta and this is another angle phi, these two angles are not actually equal, so this is the angle theta and this will be the angle phi. So the angle phi is the angle between the vector OA and the diagonal. Okay, so this sine theta in this could be written as, so this is CD upon this AC, and cos theta could be written as this AD upon this AC. We know that this AC and vector OB are equal, as these are the opposite sides of the parallelogram. This will be also vector Q. So I can write that. So this CD is equal to Q sine theta, and this AD is equal to Q cos theta. Now you can see that here in the triangle OCD, now I am considering this bigger triangle. In this bigger triangle OCD, as this is a right angle triangle, I can write, so this OC square is equal to OD square plus CD square. So this is according to the Pythagoras theorem. So this OD square, I can write this nothing at the OA plus AD square plus CD square. So this OA square plus AD square plus 2 now let us expand this bracket. OA plus AD bracket square is equal to OA square plus AD square plus 2 OA into AD plus this CD square. Now let us add these two terms. So this OA square remains as it is plus 2 OA into AD, it will remain as it is, plus AD square plus CD square. And from this triangle ADC, we can see that this AD square plus this CD square is nothing but the AC square according to the Pythagoras theorem. So OA square plus this will become AC square plus this OA into AD. Now we know that this OA is nothing but vector P, so P square. AC is nothing but vector Q, Q square, plus 2 OA, this is 2 OA, 2 P into AD. AD is nothing but the Q cos theta. So this, if R is the vector OC, then I can write that R square is equal to P square plus Q square plus 2PQ cos theta. Or I can write R is equal to square root of this whole term, P square plus Q square plus 2PQ cos theta. Okay, now if I want to draw this angle phi, so this phi or the tan phi can be given by, so this tan phi will be this CD upon OD. Okay, if I am considering this bigger triangle, so this CD is nothing but Q sine theta, which we have already calculated. This OD is nothing but OA plus AD. So this OA is nothing but the vector P plus AD is nothing but the Q cos theta. Okay, so I can write this phi is equal to tan inverse of this whole term, Q sine theta P plus Q cos theta. Okay, so if I have two vectors acting on a body and which are representing the two sides of the parallelogram, then the resultant vector is given by, so this R is equal to square root of P square plus Q square plus 2PQ cos theta. Okay, and if phi is the angle between that resultant vector with the OA, then that phi can be also calculated by using the equation phi is equal to tan inverse of q sine theta upon p plus q cos theta. Now we can see that if this theta is equal to 90 degree, so if this theta is 90 degree, so we know that sine 90 is equal to 1 and cos 90 is equal to 0. So at that time, so this phi will be tan inverse of q upon p. And when this theta is equal to 0, we know that as this sine 0 is 0, so this phi will be tan inverse of 0. So that will be 0. So this is all about the parallelogram law of the vector addition.